Behavior of light can be explained by thinking of it as an electromagnetic wave. What does it mean when we say electromagnetic wave? A wave is a periodic disturbance propagating through space. It's a disturbance. Specifically, it's a force, in this case, that affects charged particles. That's why it's called electromagnetic wave. So you have a force that affects charged particles. So the adjective electromagnetic means it's got something to do with the force that affects charged particles. Okay, the word periodic means it's repeating. So if you were to plot the wave, okay, if it that disturbance, okay, so this is disturbance here on the y-axis here. You can see it goes down, it goes back up. That's called one cycle. It goes back down, goes back up again. That's another cycle. It goes down, goes back up again. So it repeats itself over and over and over again. Okay, so that's what we mean by periodic. Now, a wave is a way for energy to be transmitted from one point in space to another. What exactly is it that is waving in an electromagnetic wave? The things that are waving are called electric and magnetic fields. The electric field is defined as the force that a charge of 1 coulomb would feel at a given location. So if you were to plot the electric field versus distance, location, for example, or distance, let's say this is let's just call this your z-axis, okay? Then if you were to plot your electric field versus c location, it might look something like this, okay? So it's strong. So here it goes up, reaches a peak. That's called a crest. So this location right here represents a crest, okay? Goes back down, reaches maximum value in the opposite direction. Okay, so this down here is called the trough, and then goes back up, and then it keeps going up again and down and then back up. So right here, at this point right here, it's complete, we say, one cycle. Okay, and that repeats itself over and over and over again. Now, at the crests, you have maximum force. That means at that particular location, if this was a snapshot of the wave at a given point in time, then at this particular location, your a charged particle would feel the strongest force, and at this location as well. So at the crests and the troughs, that's where your force would be maximized. They're just in opposite directions, okay? And where your electric field goes to zero, that's called a node, okay? That's where no force is felt, okay? Now the magnitude of your electric field at the crests and the troughs is usually represented by the symbol E naught, okay? And that's called the amplitude of the wave. So the stronger the force that would be felt at the crest and the troughs, then the greater, we say, the magnitude of the wave. There's also a magnetic field wave that is perpendicular to the electric field wave. So if this electric field is oscillating in, let's say, let's call this your YZ plane, then if you have your x-axis over here, let's call this XZ plane, then if you have your y-axis over here, then your magnetic field would be oscillating in this YZ plane instead. Okay, let me show you a picture that illustrates that. But if you do a Google search for electromagnetic wave, just click on images. These are examples of pictures that illustrate what these waves are. So here you have your red arrows represent the magnitude of the electric field at various locations. You can see there's a pattern, okay? It goes up and down and up and down. And then perpendicular to that, you have these blue arrows right here. These are the strength of the magnetic field, up and down, perpendicular to the magnetic field, okay? So that is an example of an electric field and a magnetic field oscillating, okay? And what you have here is just one snapshot in time. So an electromagnetic field, electromagnetic wave is actually a traveling wave. So it's much better to look at this using an animation. Let me see if I can find you some. Here's a very nice animation I found on electromagnetic waves. of an electromagnetic wave. You'll notice at this particular location, you notice this red arrow is going up and down, up and down. Okay, so the magnitude of the force that a charged particle would feel at this given location, it will be oscillating as an electromagnetic wave passes through. And you'll notice the blue arrow is also oscillating. Okay, and that's your magnetic field.